Hello, Year 9, and welcome to our second lesson in quadratics. Today we're going to be following on from the last class where we were expanding binomial brackets. And you may remember binomial brackets involve things like this. Two brackets, each binomial, and we would expand them by using the FOIL method. The first two terms, the outside terms get multiplied together, the inside terms, and the last terms. And we'd expand the whole thing out and we'd get our answer. So today we're going to be looking at perfect squares and a difference of two squares and how we can shortcut to avoid having to use the FOIL method. So let's get into it. Now in your notes you've got a section where you have a plus b in brackets squared. And you've got a section just under it that says proof, and this is the proof. This is actually how we generate the formula. So when you see any bracket with a squared, what does that mean? Well, let's just backtrack. What does 3 squared mean? It means 3 multiplied by 3. It means multiply 3 by itself 2 times. What does x mean if I square it? It means x multiplied by x. So you could ask the question, what does a plus b in brackets mean if it is squared? It means multiply a plus b in brackets by a plus b in brackets. The bracket is squared. And as soon as we see that, we can see this is very similar to what we were doing last class. We have two brackets and we can FOIL them. A times a times b times a, b times b. That was the order, and I did it quickly. Let's see the process. Here we go. The first two terms in each bracket. A times a is a squared. Now we go for the outside terms. Remember, we're using the FOIL method. So we've just used the first two terms. Now we're going for the outside terms, which are a and b. A times b is ab, and it's positive ab. Now we're going to go for the inside terms, which is b times a. B times a is ba or ab. Doesn't matter what order we put the letters in. And finally, we now have the L, which is the last term in each bracket. B times b is b squared. You can see that we have an ab there. That's plus 1ab plus another 1ab, which means I've got 2 ab's. So that is my final answer, which means a plus b in brackets squared actually ends up equaling a squared plus 2 lots of ab plus b squared. And that's a formula that you could actually memorize and learn if you wish. But I tend to memorize a pattern. And so we'll talk about that in a moment. But let's look at the second type of perfect square. And that's when we still have a bracket, but instead of having a plus sign, we actually have a minus sign in the bracket. So we know it's squared. As soon as you square something, it means it's multiplied by itself. So it's the bracket a take b multiplied by the bracket a take b. And we're going to go through this same process where we will FOIL it out. So the first two terms, a times a squared. The outside terms, a times negative b. Well, a times b is ab, so the answer would be negative ab. Now the inside terms, negative b times a is negative ba, but we're going to write negative ab because the order doesn't matter when you're writing the letters down. And the last terms, a negative b times a negative b. Well, I know a minus times a minus gives a plus, and b times b is b squared. Now we also have like terms here. There's an ab, there's an ab, minus one of them, minus another one of them is minus 2ab. So we get a squared minus 2ab plus b squared, and that's our second formula, if you like. Our third type is called a difference of two squares, and that's where we have two brackets that both start with the same thing, both finish with the same thing, but one bracket has a plus and one bracket has a minus. Let's just look at what we did before. When we had a plus b squared, that was a plus b times a plus b. Then we did a minus b squared, which was a minus b times a minus b. Now we actually have a plus b times a minus b. So you can see the three different cases. First case, both brackets have exactly the same things with pluses. Both brackets are identical with minuses. Both brackets start with the same letter, finish with the same letter, but one has a plus and one has a minus. And that's the separate case we're doing now, and it's called a difference of two squares. So we've got our brackets. We can still FOIL it out. First, outside, inside, last. Let's do that. The first terms, a times a is a squared. The outside terms, remember we're FOILing, so just in case you'd forgotten. The outside terms, a times negative b is negative ab. Now the inside terms, a positive b times an a is a positive ba or positive ab. And the last terms, a positive b times a negative b gives negative b squared. Now when I look at the like terms, I've got negative 1ab plus 1ab, which gives no ab's. They just cancel each other out. They actually disappear. So I'm just left with a squared minus b squared. And that's our third proof. So let's try doing some questions using the two different techniques. The technique we learned in exercise 8a, the FOIL method, and I'm going to teach you a shortcut method after we've done our slightly longer method. Now, here we go. For example 1, part A. X take 3 and bracket squared is what we're trying to expand. Well, we know when we see a bracket and it has a squared, that bracket is multiplied by itself. Now I'm going to FOIL it out. So FOIL, first, outside, inside, last. Let's do the first terms. X times x is x squared. X times negative 3, negative 3x. Now the inside terms. Negative 3 times x, negative 3x. And finally, the last two terms, the negative 3 times the negative 3 gives positive 9. We have like terms, negative 3x, take away another 3x gives negative 6x. So there is our final answer. So we can actually get that answer using nothing new, the same technique that we used when we were doing exercise 8a. Let's try a slightly shorter method. I'm going to call this the smiley face or the happy face method. So we're going to put on our smiley face or our happy face. And remember, when you have a happy face, this is what I am expecting. 2 big eyes and a big smile. So that's what I'm looking for. So let's go about this process and see if we can make sense of what I'm talking about when I talk about a happy face. Well, when you're using the shortcut method, we're dealing with our eye first. And that is this part. So we take the x and it has to be squared. So we square the x and we get x squared. Now the next part's the tricky part because the next part we are going to deal with the smile, but not just a single smile, it's a double smile because maths is twice the fun of anything else that exists. So let's go through it. We put our little smile there. Now we're going to multiply. Let's get rid of that smile there and that face so that we can see. We're going to multiply our two terms together and then double it. That's the smile. Double the fun because it's maths. Woohoo! Here we go. What is, with our smile, what is the x times the 3? Well, x times 3 is 3x. If you double 3x, you get 6x. Because there's a minus there, we're going to get minus 6x. So we times the x and the 3 together to get 3x and double it to get 6x, and the minus carries across. So that was the hardest part about this shortcut. The next part is we deal with our second eye. You can see my smile. There's my eye, there's my eye, there's my smile. 3 times 3 gives 9, and we know a minus 3 times a minus 3 gives plus 9. And so we went to the answer instantly. Let's try 1b, and I'm going to try using the shortcut method. So we've got 3x plus 5 in brackets squared. Let's go for our I. 3x times 3x is, 3 times 3 is 9, x times x squared. 3x times 3x is 9x squared. The tricky part now, what's 3x times 5? Well, I know 3 times 5 is 15, so 3x times 5 is 15x. And when you double that, double 15 and you get 30x. Now I've got to put my last I in. 5 times 5 is 25, and it's plus because plus 5 times plus 5 gives plus 25. That's the answer. Now you could have done this. You could have actually written the bracket out twice, and then you could have gone FOIL, first times first, 9x squared. Outside, 3x times 5 is 15x. Inside, 5 times 3x is 15x. And last, 5 times 5 is 25. And then we group our like terms together, and you'll notice there is a 15x and a 15x, which when you double it gives you 30x. So you get the same answer. See how much faster it is if you learn the smiley face or the happy face technique. If you forget it, you can always go back to FOIL, providing you write the brackets out twice. Let's try example 2. This is not a happy face question. Happy face questions work for ones like, whoa. Let's go on to example 2. Now this is a little bit different. This is not a happy face question, because when you look at this, you'll notice that this bracket has a plus, this bracket has a minus. The questions that we did earlier were ones like this. When you have a bracket with a squared, and it doesn't matter whether it was positive or negative, you can smiley face technique them. But when they're not the same bracket with a squared, they're different brackets, well, what do? Well, let's FOIL the question, just like we did in exercise 8a. X times x, x squared. Outside, x times minus 3, minus 3x. Now the inside, 3 times x plus 3x. And the last terms, positive 3 times a negative 3, negative 9. And notice, when you look at this question, negative 3x plus 3x, they are the same. Negative 3 plus 3 gives 0. They're going to cancel each other out. And you're left with x squared take 9. So, could that have been done quicker? It certainly could have. We could have recognized the type of question that it is, where each bracket starts with the same thing and finishes with the same thing. They both start with x and finish with 3, but one bracket is positive and one bracket is negative. You could also have this same question written like this, where the first bracket was negative and the second bracket was positive. It wouldn't matter if the brackets are identical, except for the difference between them in the signs. Then we can actually, instead of using FOIL, we just use FL. We don't worry about the outside and inside because they will always cancel. We saw how they cancelled there. The minus 3x and the plus 3x cancelled. They always cancel if it's this style of question. So we could look at it and we could go first times the first. X times x, x squared. 3 times minus 3, minus 9. And there's my answer. Let's see if we recognize this question, how we could do this quickly. So you've got 2x, 2x, both brackets begin with the same thing. 3y and 3y, they finish with the same thing, but one bracket has a plus, one bracket has a minus, which means I could get away with just using FL. But I'll show you the full working as though I FOILed it out. So let's FOIL this out. First terms, 2x times 2x, 4x squared. Outside terms, 2 times negative 3 is negative 6, so you're going to get negative 6xy in this case. The inside terms are 3 times 2 is 6, plus you got the yx, 6yx or 6xy. And the last terms, positive 3 times a negative 3. So we're looking at the last terms. Positive 3 here times negative 3 here gives negative 9y squared. And you can see that a minus 6xy and a plus 6xy cancel each other out. And it leaves me with 4x squared, take 9y squared. So how could I have done this question here faster? I could have looked at it, recognised that brackets are the same except for the plus and the minus. So let's FL. 2x times 2x, 4x squared. Positive 3 times a negative 3, negative 9, and the y times y gives y squared, which is the answer. So that's much faster to do it that way. Let's just try one more question just to see how it goes. Let's try this one. 5x plus 7, 5x minus 7. Both brackets are different except for the plus and the minus. Both brackets are the same except for the positive and the negative, which makes them different brackets. So if I FL 5x times 5x, 25x squared. Positive 7 times a negative 7, negative 49, finished. So there are shortcuts that you can use. Practice doing them. These are the sorts of things that will make life a whole lot easier down the track. Have fun trying this, do your best, and we'll go through them if you get stuck when I get back. Bye for now.